What if I told you that, before this year is over, something brighter than every star in the night sky could rise just before dawn? Not a planet, not a spacecraft, but a frozen visitor from the edge of the solar system, with a tail that could stretch across the sky. It's called Comet C / 2023 A3, Tsuchinshan Atlas. And if it lives up to current predictions, it could be the brightest comet we've seen in over half a century. Some astronomers believe it may even be visible in broad daylight. Others warn it might break apart into dust just days before its closest approach, like Comet ISON did in 2013. But make no mistake, whether it survives or not, this comet is already rewriting the rulebook. Its orbit is long and sharp, likely its first and only visit to the inner solar system. Its speed is breathtaking, racing toward the sun at over 60 kilometers per second. Its brightness curve is climbing, fast. And best of all, it's headed straight toward the perfect position for viewing from Earth. So where did this thing come from? How bright will it really get? And what do astronomers hope to learn from it? To answer that, we need to go back to January 2023, when a tiny flicker of light appeared in two separate telescopes on opposite sides of the Earth. It was just another January night in 2023. At observatories in Hawaii and eastern China, automated telescopes scan the skies, like they do every night, looking for things that move. Most of what they find are familiar: main belt asteroids, space junk, sometimes a faint satellite glinting in the dark. But on this night, both NASA's Atlas survey and China's Purple Mountain Observatory spotted something different. A dim, slow-moving object had appeared in multiple exposures. Not fast enough to be nearby, not steady enough to be a star. On its own, it might have been dismissed as background noise. But once both teams cross-referenced observations, they realized this object wasn't just drifting, it was approaching. Fast. Within days, astronomers searched through archived data from other telescopes and found pre-discovery images dating back to late December and even early November. These earlier detections provided a longer observation arc, and with that, orbital calculations became more precise. What they found startled them. C / 2023. A3 wasn't following a cozy elliptical orbit like short-period comets do. Instead, it was on a sharply elongated, nearly parabolic trajectory, meaning it likely originated from the Oort Cloud, a shell of icy debris surrounding our solar system, tens of thousands of astronomical units away. Even more unusual was its inclination, tilted at nearly 40 degrees compared to the orbital plane of the planets. This meant the comet was coming in from above, not tangled in the usual gravitational ballet between Jupiter and the Sun. Its approach would offer clear visibility from both hemispheres, free from planetary interference. And then came the projections. By the time it reached perihelion, its closest point to the Sun, it would be well inside the orbit of Mercury. And its Earth passage, even better. Just 0.47 astronomical units away. Not close enough to be dangerous, but close enough to become a spectacle. Its apparent magnitude, a measure of brightness, was already on an aggressive upward curve. Astronomers began whispering, could this be our generation's great comet? In every great comet discovery, there's a moment where routine data becomes history. For Hale-Bopp, that moment was in 1995. For Neowise, it came in 2020. For C2023, A3. That moment happened quietly in January 2023 when two separate telescopes, half a world apart, spotted something ancient returning to the light. And now, it's on a path that could make it the most memorable comet since Hale-Bopp. By now, the question on everyone's mind is, how bright will Comet C2023 A3 become? And the truth is, it could go either way. Astronomers use mathematical models to estimate how comets brighten as they approach the sun. These models rely on three key factors: the comet's absolute magnitude, how bright it would appear at a standard distance, its distance from Earth and the sun over time, its n value, a brightness coefficient that reflects how fast its activity increases. For C/2023 A3, the numbers look incredibly promising. If current projections hold, it could reach a magnitude of -1, possibly even -4 or -5, making it brighter than Venus, and potentially visible in broad daylight when positioned just above the horizon at dawn. But before you set your alarm clocks for October, there's something else to consider. Comets lie. They're volatile, unpredictable, and often disappoint. Some suddenly dim. Others break apart before reaching their brightest. And a few, like Comet ISON in 2013, disintegrate entirely in the heat of the sun. So what makes astronomers cautiously optimistic about A3? First, its trajectory. Unlike ISON, which plunged dangerously close to the sun's surface, C/2023 A3 will remain at a safer distance, around 0.39 astronomical units at perihelion. That's inside Mercury's orbit, but far enough to avoid tidal shredding or total vaporization, at least in theory. Second, its dust activity. Recent observations already show a growing coma and signs of a dust tail, which usually indicates healthy outgassing. Comets that become bright often have strong dust production, not just gas, because dust reflects far more sunlight. This is exactly what made Comet N EOWISE so photogenic in 2020. And third, its structure. Based on early light curves, A3's nucleus appears stable, with no signs of chaotic tumbling or rapid spin-up, which can tear a comet apart from within. But that doesn't mean it's out of danger. As the comet nears the sun, the solar heat could trigger internal stresses, microfractures, or sudden outbursts, violent eruptions of gas and dust that change its brightness and spin. And here's the twist. Sometimes these outbursts make a comet brighter, dramatically so, right before they break apart. So we're walking a cosmic tightrope. If A3 holds together, we could witness one of the most beautiful sky shows in modern history. If not, we might only get a fleeting glimpse before it fades into a cloud of dust. Either way, something big is coming. Let's talk about timing. Because even the brightest comet in the universe means nothing if you can't see it. Fortunately, Comet 2023, A3 isn't just promising in terms of brightness. It's also taking a path that's nearly perfect for sky watchers on Earth. Here's why. The comet is set to reach perihelion, its closest point to the sun, on October 10th, 2024. At that moment, it will be just 0.39 astronomical units from the sun, close enough for solar heating to activate intense outgassing and dust release, making it as bright as it's ever going to get. But here's the real advantage. Just 3 days later, on October 13th, it will make its closest approach to Earth, at a distance of 0.47 astronomical units. That rare timing alignment, perihelion followed almost immediately by Earth flyby, is what makes this comet so visually promising. But brightness alone doesn't guarantee visibility. What matters is geometry, the angle between the comet, the Earth, and the Sun. And in this case, everything aligns beautifully. C2023 A3 will appear in the eastern sky just before sunrise, rising higher each day as it exits the sun's glare and enters Earth's optimal viewing window. In early October, it may be hard to spot at first, low on the horizon. But by mid to late October, the viewing conditions improve dramatically. The comet will be best visible from mid-latitudes in both hemispheres, especially in locations with dark skies and unobstructed views to the east. And that's not all. Because of its high orbital inclination, the comet will rise at a steep angle, which helps separate it from the sun's glare more quickly than most low-inclination comets. This gives observers more pre-dawn time to photograph or simply marvel at it. And, if the comet survives perihelion intact, it will emerge again in November, still visible, but now in the early evening sky for observers in the southern hemisphere. This dual-phase visibility, dawn in the north, dusk in the south, is exceedingly rare. Most comets are one-shot deals, seen only from certain latitudes at inconvenient hours or drowned in twilight. But A3? If it performs as predicted, it might just become a global comet, visible to more people on Earth than any comet in recent memory. So mark your calendars. October 10th to 25th. That's your window. And if you're lucky enough to have clear skies, you'll be standing face to face with a traveler that hasn't seen the sun in millions of years and may never return again. We're getting closer. In a few months, Comet C2023 A3 will reach the moment that decides everything, its closest encounter with the sun. Right now, astronomers around the world are holding their breath, not out of fear for Earth, but for the comet itself. Because here's the truth. Most comets don't survive this journey. You see, a comet is not a solid rock like an asteroid. It's more like a dirty snowball, fragile, porous, held together by weak gravity and ice. And as it dives into the inner solar system, the sun turns from a distant light into a cosmic blowtorch. Thermal stress builds, gas jets erupt, and under the wrong conditions, the entire nucleus can shatter. We've seen this before, painfully. In 2013, Comet ISON was hyped as the comet of the century. Predicted to shine brighter than the moon, it was set to be the most spectacular sight in modern memory. Instead, it crumbled just hours before perihelion. All that remained was a fading cloud of dust and disappointment. So what makes astronomers hope C2023 A3 won't meet the same fate? First, distance. ISON got too close, just 0.02 AU from the sun. That's practically grazing the solar corona. A3's perihelion is safer, 0.39 AU. Still hot, over 400 degrees C, but far enough to avoid being torn apart by tidal forces. Second, size. While estimates vary, A3's nucleus could be 3 to 5 kilometers wide, much larger than ISON's. That gives it more mass to resist structural failure. And third, current stability. So far, the light curve shows no wild fluctuations, no evidence of sudden spin-up, and no unexpected fading. But that doesn't mean we're in the clear. Many comets fail without warning. They hold together until they don't. Astronomers are watching for red flags, outbursts, sudden spikes in brightness caused by volatile gases bursting through the surface. Fragmentation, tiny pieces breaking off, often invisible at first. Rotation acceleration, asymmetrical gas jets pushing the comet into a death spin. Even if it begins to break apart, that might not be the end. In fact, some of the most stunning comet displays in history came from disintegrating visitors, their shattered fragments scattering dust across the sky, glowing like ghost trails in the dawn light. So yes, destruction is possible, but so is transformation. What looks like a cosmic failure might become one of the most beautiful sky shows of the decade. We'll only know when it happens, and that's why the next few months will be critical. This isn't just a question of brightness, it's a test of survival, and C2023A3 is running out of time. Whether Comet C 2023A3 survives its encounter with the Sun or not, one thing is already clear. This is more than just a sky show. It's an opportunity, a fleeting window into the raw, untouched materials that built our solar system. You see, comets like A3 are time capsules. They formed over 4.5 billion years ago, far beyond the orbits of the outermost planets, in a region so cold and distant that change happens almost never. Their ices preserve the original ingredients of the early solar nebula: water, carbon-based molecules, complex organics, the very same compounds that may have seeded life on Earth. By observing a comet up close, tracking its composition, structure, activity, and decay, scientists can piece together how planets like ours formed, and perhaps how life began. Every image captured, every spectrum analyzed, every dust particle studied, it's all part of a larger puzzle. A puzzle that stretches from icy comets to blue oceans and living cells. In recent years, missions like Rosetta, Stardust, and Deep Impact have brought us closer to cometary science than ever before. But most of our data still comes from Earth-based observations, and that's where C 2023A3 comes in. Because unlike many comets that stay faint or hide behind the sun, A3 is bright, close, and favorably placed. It gives us a rare chance to study dust production rates in real time, monitor the evolution of a cometary coma and tail across different solar distances, detect potential fragments or outbursts which reveal internal composition, and even measure the polarization of light reflecting off its dust, a key to understanding particle size and structure. And it's not just professionals. Thanks to modern telescopes, amateur astronomers across the globe are contributing valuable data, imaging tail dynamics, reporting magnitude changes, and helping triangulate position in real time. Websites like the Minor Planet Center, JPL Horizons, and the Astronomer's Telegram are already lighting up with daily updates on A3's behavior. This is a moment of collective discovery, a chance for humans everywhere to look up, contribute, and learn. Because comets like A3 don't just come around every decade. Some of them never return at all. And when they pass, they leave more than dust trails. They leave questions. They leave data. And sometimes, they leave answers we weren't expecting. So, what do we make of all this? A distant ice ball is heading toward the sun. It might shine. It might break apart. It might vanish forever. To some, it's just another celestial curiosity. Beautiful, yes, but ultimately irrelevant. But to others, it's a reminder. A reminder that we're part of something far older, far bigger, and far more mysterious than we'll ever fully understand. Because Comet C 2023A3 isn't just a hunk of ice and dust. It's a messenger a frozen artifact from the dawn of the solar system, now whispering its secrets across millions of kilometers, to a species that just a few hundred years ago believed comets were omens of doom. And now we track them with precision. We photograph them in stunning detail. We debate their origins, model their decay, and share their stories across the globe in real time. We've come a long way. But maybe, just maybe, comets like A3 are here to show us how much farther we still have to go. They challenge our instruments. They defy our predictions. And they invite us, for a brief, beautiful moment, to look up. So whether C2023, A3 dazzles, or disintegrates, one thing is certain. It has already done its job. It has brought us together, scientists and stargazers, teachers and students, professionals and amateurs, all focused on one tiny glowing point in the sky. It has reminded us that there's still wonder out there, waiting to be seen, measured, and understood. And perhaps, waiting to change the way we see ourselves. So set your alarms, charge your cameras, open your skies, because for a few weeks later this year, a traveler from the edge of time will grace our world with light and then disappear into darkness, leaving only questions behind.